Well, I just want to say yay for shortcuts. Everyone is always asking me, is there an easier way, a quicker way to do this? Well, when it comes to dividing polynomials, there is going to be a shorter method, and that is going to be called the synthetic division method. And we're going to learn to use synthetic division, divide a polynomial by a linear factor, and applying the remainder theorem. Well, of course, this is a quicker method of doing polynomial division, but it is limited to your divisor must be a linear factor, which means it's x to the first power. And in that case, moving forward, we will be able to distinguish between long division or synthetic division depending on, what your divisor is and which method proves the easiest for that scenario. But for this purpose, we're going to make sure that this lesson we're using synthetic division, and then after that, you can use whichever method you like, but I think you'll probably find that you like the synthetic method better because it genuinely is going to be easier or quicker. So my remainder theorem, the remainder theorem basically states that, well, let's just say that whatever is left over, if I divide a polynomial into another polynomial and it equals 0, then that is going to be a root. But specifically, the remainder theorem states that if a polynomial is divided by a linear factor, then the remainder is your f of k, your output. Okay, and then the synthetic division is just a shortcut of that, and we will show some examples of that here in a moment. But just remember that in long division, of course, we would set it up like that, and then we would have a whole bunch of math going on here, and then we would go x to the fourth minus 3x to the cubed, and then we would subtract, and we would work our ways down there. And we know here that this is going to be my divisor. Sorry, spelled that wrong. It's going to be my divisor, and for synthetic division, we use our divisor is going to be this form right here, which is x minus k. So in synthetic division, we would set this up as you would divide by 3 because that is the value of k. And what we're going to be dividing into it is just going to be the coefficients. So I'd have 1, -1, -12, 9, and 27. And as you can see, these are my coefficients to my polynomials over here, or to my terms over here. And when I do that, 3, if you'll notice, is my k value. So where my other long division divisor was x minus 3, I'm going to divide just by 3 because that would actually would have been the root. So what you do here is, it's very simple. We're going to simply carry down, and then we're going to multiply, and then we're going to carry over. And so just setting the problem up is going to prove to be a lot easier. So let's go ahead and move on to this example right here. So we have 2x to the third plus 11x squared plus 18x plus 9 is divided by x plus 3. All right, so if I write this in the form x minus -3, okay? So that means my k value that I'm going to be dividing by, my divisor, is going to be -3. And then I'm going to set my synthetic division up using just my coefficients and constants. So I'm going to have 2, 11, 18, and 9. So let's see here. To start the division process, of course, I need to go ahead and carry my 2 down. And then I'm going to go ahead and multiply -3 and 2. And that's going to give me -6. And I'm going to add down. That is going to give me -5. And I'm going to multiply again. -3 and -5 is going to give me 15. And then I'm going to multiply down, and that is going, or add down. That is going to that is going to give me a 3. You may notice I just made a correction. And then negative 3 times 3 is going to be a negative 9, and I'm going to add that down and I'm going to get 0. So this is going to be my remainder. So since that remainder is 0, that does mean it's a root. Again, this was my k value, so I know that that factor is going to look like x plus 3, you know, because it's this thing right here. And then now, we started off as x to the third, but if I had just divided it by 1 power of x, that means I'm down 1, right? So it means this is going to be 2x to the second plus 5x plus 3 is going to be the other quotient. So that is my quotient. And then there we go. We were able to do synthetic division pretty quick that way. And we'll do another example. As we look here, it says that the volume of a rectangular prism is this. So it looks like I have 2x cubed plus 9x squared minus 8x minus 36 is going to be the volume. And we know that volume is going to be length times width times height. So that's actually three factors that we have there, but they're giving us the height. And they're telling us my height is going to be equal to x plus 2. And it says using synthetic division, what is the area of the base? Well, the area of the base is going to be these two multiplied together. So that would be the quotient. That would be what's left over in my division problem. So what I'm going to do is I'm going to go ahead and divide this by, take out the 8, so I know that h is going to be 3. I don't know where I got 3 from. X minus, and then negative 2, so my k value is going to be negative 2. And so I am going to be able to do my synthetic division by dividing by negative 2, and then of course bringing down my coefficients, 2, 9, negative 8, negative 36. And again, first step is to bring my 2 down, and then I'm going to multiply 2 times negative 2 is going to be negative 4. Add those down, I get 5. 5 times negative 2 is going to be negative 10. Add those 2 down, I get negative 18. And 18 times 2 is going to be 36. Add those down, and I get 0. So 0 means that that is my remainder, and that it is a root. I do know that, so it's a factor, root or factor. And then this form right here, I know that that was, again, going to be k, which is h minus k, or h minus a negative 2, which is h plus 2, or I'm sorry, I guess x, right? I should be looking at x. X plus 2 is going to be one factor. And then my area is going to be the quotient that was left over. So again, I am going to have, this was x to the third, so this is going to become x to the second, x to the first, and then constants. So my next quotient is going to be 2x squared plus 5x minus 18, and that was synthetic division. Now I could turn around and factor this further and find out what is my length and height, or length and width. They didn't ask me to do that, so I'm not going to do that at this point in time. But I do know that this was my height, and this was the area of the base of the rectangular prism. So let's see here. They've given us some more information, and it says finding all the factors. Now we're going to go out and we're going to find out all the factors. And it says one factor of this function, f of x equals 5x to the third plus 5x squared minus 170x plus 280 is this, x plus 7, which is x minus a negative 7. What are all the roots of this function? Well, they're telling us one of the roots is negative 7. You know, that's one of my roots. So if I go ahead and I'm going to divide this polynomial by negative 7, or referred to as my k, right, h minus k, I'm going to use my coefficients to do my division. So I'm going to have 5x cubed. What am I doing? I'm only going to have a 5. 5, 5, negative 170, and 280. And my division is going to be bring one number down, and then I'm going to multiply. I'm going to add down, and I'm going to multiply. I'm going to add down, and I'm going to multiply, and I'm going to have a remainder of 0. All right, so there's my remainder, so I know that this one factor was x plus 7, and I know that this factor is going to be 5x squared minus 30 plus 40. And let's see, what else can I do here? I have x plus 7, and I could do some more division, but I should be able to factor this. And taking this over here, I have 5x squared minus 30x plus 40. So I have 5x, x, and then what factors of 40 times 5, are going to give me something that I add up to get negative 30, and I think, I know my factors are both going to be negative because when I combine like terms, my middle term is going to be negative, and this in term is positive, so I'm looking for factors of 40, negative factors of 40 that will combine to give me, when I do the math out here. So let's see here. And I'm looking at it and I'm saying, hey, how about 2 and 20? Because when I multiply those, I get 40. But I'm thinking here, when I do my combinations, this would be 2x, and the outer one would be negative 100x, which isn't what I'm looking for. I'm looking for numbers that will combine and give me this. But it looks like I thought about it as I was plugging those values in. I'm going to reverse that 2 and 20, okay? I'm going to put 20 over here and 2 over here, and what I get when I multiply negative 20 times x is negative 20x, and then 5 times negative 2 is going to be negative 10x, so that together is going to give me negative 30x. So I can come over here and say my other factors are 5x minus 20 and x minus 2. So there you go. Those are some potential factors of the possible. Now again, this, this is a polynomial that can still be factored. That's why we ended up breaking it down here more. And let's see, that's polynomial or synthetic division in a nutshell. Remember that we're using this form of division, h minus k, so I'm going to be dividing by k into my polynomial. And then my degree of my quotient is going to drop 1 because accounting for what we are dividing out of it. So again, synthetic division is a shortcut. You may find it much quicker than long division. You just have to make sure that you're using it within the allowable constraints of only dividing by a linear factor. And let's see here. So I'm trying to think if we're missing anything. I think that's probably enough to get you started on your assignment, and we'll see how it goes from here.